Okay, let's talk about errors now. So let's imagine these two worlds. We have H0, and now let's work with a third situation. Let's work a scenario in which the number here is 6.1 and 5. So the difference in depression is 1.1. So it's very close to the border. Is the main number beyond the critical values? Yes, it is. It falls in the rejection region. So we assume this main number is coming from the world 1 population with value 1.1, hypothetically. And this is the hypothetical H1 distribution derived from the hypothetical population. You see, this is sort of what we did in the L distributions class. And this is it, okay? And also, by the way, this H1 distribution doesn't include 0. So it's the other method that we're talking about before, right? This doesn't include 0. Anyways, so how can you be so sure, though? How can you be so sure? Well, never sure, right? That's the whole point of statistics. But this is our world 1 distribution. This is our world 0 distribution, okay? This is the 0. This is the 1.1. Now, remember the cumulative thing. If we start from there, it ends at 4%, right? So the world 0, there's a 4% chance that, so let's look at this together. If you take 100 samples from world 0, okay? Only 4 of those samples will be 1.1 or higher, right? Because that's what the 4% is telling us. Represented by the p-value, p equals 0.04, which is the p-value that we would have found in this situation. It's just below 0.052, just below 0.05, which is the alpha rule that we're talking about. So it's just enough to reject the null hypothesis, but that's it. So the meaning, there's only a 4% chance that 1.1 is actually coming from world 0, and that there's no difference between histogram and no histogram. What do I mean by that? There's only a 4% chance that this sample with value 1.1 is comprised of people who are way too prone to depression. You see, it would have to be an exception. And the chances of that are very, 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 very slim. That's why you ask me, what should I do in this situation? Because there's still a 4% chance that it's coming from world 0. Well, here's what we do. Didn't we agree that we're going to work with a 5% alpha 0.05, so a 5%, 95% confidence? Well, yes. So the main number fell in the rejection region. Simple. We're going to consider it's most likely coming from world 1, the other one. So we'll reject the null hypothesis. But keep in mind, there's still a 4% chance that the main number is actually coming from world 0. So this is the criticism that we have to have. Now let's talk about errors type 1 and 2. Okay. We have H0 distribution, H1 distribution. Let's bring them together. Okay. Let's expand them a little bit more. And now let's remove all the unnecessary numbers. The only thing that matters here is that H1 has a number of 1.1 and H0 has a number of 0, right? That's the estimation. And the critical value for H0 is 1, and 1.1 is just outside the critical value. Okay, so the alpha here is 0.05. This is what we call the chance of a type 1 error when we're dealing with a 95% confidence interval. So alpha is always the chance of a type 1 error. You can also remember this definition. What is a type 1 error? It's a false positive. It's a situation in which we assume that the main number in the population is 1.1 when it's actually 0. So this is that thing, this is, there's only we're working with a maximum 5% chance of a false positive. Okay. So 1.1 could be coming from world 0. 1.1 could be just an exception sample coming from a world in which depression, there's no depression if you use histogram or not, right? Cool. Let's talk about the p-value though. The p-value now is this area. Keep in mind that the p-value goes on both sides. We'll talk about that later because this is a two-sided hypothesis. But for now, just the p-value represents how likely it is that this number came from world 0, right? It's a 4% chance that the main number of the population is actually 0. Or there's a 4% chance that this 1.1 is coming from a world 0 population. It's the same thing as saying that. Okay. Beta, on the other hand, is the area overlapping H1, the H1 distribution, and the inner area of your critical value. Okay. So the critical value here was 1. So this is the chance of a type 2 error, which is the chance of a false negative. So let's say you have that example where you have a sample, and this sample had a difference of 0.5, and we're plugging that number here, and we're like, okay, is the 0.5, is it falling off the cliff? No, it's not, right? It falls within the H0 distribution. But by not rejecting this 0.5, if we're too conservative, that's also a problem. If you don't reject it, there's a chance that this 0.5 is coming from the H1 world. And then what do? Well, it's going to suck because you'll never know. So this is the chance of a type 2 error. It's the situation when we assume that the mean number in the population is 0 when it's actually not 0. Now, here are the things that we defined. And we defined alpha, which is this region in red, defined P, which is this region in orange, the smaller one. We defined beta, which is this region in purple, and we defined power. Power is literally 1 minus beta, because it's the entirety of the distribution H1 minus the area of beta. And power is just the thing you're going to be talking about later. It's an indicator of how well you know that you're catching all of the H1s, because here it's kind of okay, because you're not catching all of the H1s. You're still missing some of the H1s, some of the samples that fall in the H1 to the H0. Because you see, the problem here, if you didn't understand anything I said, it's fine. The problem here is that this is an area of overlap. And in this area, we don't know if things are coming from here or from here. That's the main point, okay? So just to finalize, power is 1 represented by this white area, is the entirety of the distribution minus beta is equal to this green area.